In this podcast episode, Andrew Gallimore, a neuroscientist with a background in chemistry, pharmacology, and computational neuroscience, discusses his extensive research on psychedelics, particularly DMT. Originally from the UK, Gallimore's academic journey began with chemistry and pharmacology, driven by a fascination with how drug molecules interact with the brain to alter subjective experience. He later pursued a PhD in biochemistry and transitioned into computational neuroscience, eventually moving to Okinawa, Japan, where he conducted research on brain modeling. About 3 years prior to the interview, Gallimore left academia to focus on writing and exploring psychedelics outside the constraints of university life. His work now centers on understanding the neuroscience behind psychedelics, with a special emphasis on DMT, which he regards as a profound and unresolved mystery in science. His new book, Death by Astonishment, delves into the history, science, and enigmatic nature of DMT, tracing its use from Amazonian indigenous cultures to modern scientific inquiry. Gallimore played a foundational role in conceptualizing the extended state DMT, or DMTX, a method designed to stabilize and prolong the DMT experience through controlled intravenous infusion. Alongside Rick Strassman, he proposed that DMT's unique pharmacology could allow for maintaining steady brain DMT levels, enabling subjects to remain in a breakthrough state for extended periods, such as 30 minutes to an hour or more. This idea was later adopted and implemented by Imperial College London, where researchers conducted pilot studies with a small number of volunteers to test safety and tolerability. Although the initial studies involved only about 11 participants, they demonstrated that it was possible to hold subjects in a stable DMT state, opening the door to more in-depth exploration. Gallimore notes that other groups have extended these sessions even further, with some lasting up to 6 hours at sub-breakthrough doses, suggesting the potential for long-term study of the DMT state and its associated experiences. The conversation highlights the distinctions between DMT administered via DMTX, or vaporization, and the traditional Amazonian brew ayahuasca. While ayahuasca contains DMT, it also includes monoamine oxidase inhibitors that prolong the experience by slowing DMT metabolism. However, ayahuasca's effects are accompanied by purging and other physical side effects, which can be unpleasant and are not ideal for scientific study. Gallimore explains that ayahuasca's DMT blood levels rise and fall gradually, making it impossible to stabilize the experience pharmacokinetically. In contrast, DMTX allows for precise control of DMT concentration in the bloodstream, enabling a steady-state experience without the side effects of ayahuasca. Additionally, the intensity of DMTX experiences tends to be higher, as ayahuasca generally produces milder effects due to lower peak DMT levels. A significant portion of the discussion focuses on the interaction between psychedelics and serotonin receptors, particularly the 5-HT2A receptor, which is central to psychedelic effects. Gallimore clarifies common misconceptions about serotonin depletion following psychedelic use. Unlike other psychedelics such as LSD or psilocybin, which cause rapid desensitization and short-term tolerance by downregulating serotonin receptors, DMT does not significantly desensitize these receptors. This unique property allows DMT to be administered repeatedly or maintained at high levels without the need to increase dosage to overcome tolerance. Gallimore emphasizes that while the intense mental and psychological stimulation from DMT can be taxing, there is no evidence that it causes lasting serotonin depletion or receptor damage. The brain's response to DMT is distinct and allows for prolonged exposure without the typical tolerance seen with other psychedelics. Gallimore provides an in-depth overview of the history and findings of brain imaging studies involving psychedelics. Early EEG studies from the 1950s showed that psychedelics like mescaline reduce alpha wave power in the brain, even with eyes closed, indicating that the brain generates vivid sensory imagery internally. This desynchronization of alpha waves suggests that the brain is actively producing the complex visual and auditory hallucinations characteristic of psychedelic states. More recent functional MRI studies, particularly those from Imperial College London, have revealed that psychedelics increase excitability in cortical neurons by stimulating 5-HT2A receptors. This leads to a loosening of neural activity, allowing the brain to explore a wider range of states and generate fluid, dynamic perceptions. Gallimore likens this to heating glass until it becomes malleable, reflecting the subjective experience of objects morphing and reality becoming more fluid under psychedelics. The conversation delves into the role of the visual cortex and hippocampus in psychedelic experiences. Gallimore references the pioneering work of Wilder Penfield, who electrically stimulated different brain regions in awake patients and elicited visual and memory-related hallucinations. Stimulation of the primary visual cortex produced simple geometric shapes, while higher cortical areas generated complex objects and faces. Stimulation near the hippocampus triggered vivid memory recall. This hierarchy explains how psychedelics can produce a range of experiences from geometric patterns to reliving past memories. Gallimore also notes parallels with psychotic hallucinations, where temporal lobe activity near the hippocampus is heightened, suggesting that hallucinations often draw from stored memories. Psychedelics appear to activate this entire cortical hierarchy, producing both novel imagery and memory-based content. Gallimore emphasizes that DMT experiences are unlike typical hallucinations or dreams. While dreams and psychotic hallucinations rely on the brain's learned models of the world, DMT often produces hyperreal, hyperdimensional, and alien landscapes filled with entities that defy conventional explanation. These worlds are remarkably detailed, coherent, and dynamic, suggesting that the brain may be receiving information from an unknown external source or intelligence. He posits that DMT might act as a molecular communication technology, gating access to an alternate realm or source of information. This hypothesis is supported by recent studies showing that under DMT, the brain exhibits forward-flowing waves from the visual cortex even with eyes closed, mimicking real sensory input. Such findings challenge the notion that DMT experiences are purely internally generated hallucinations and open the possibility of genuine interaction with otherworldly intelligences. The discussion turns to the molecular basis of psychedelic effects, highlighting the work of Alexander Sasha Shulgin, a legendary chemist who synthesized hundreds of psychedelic compounds. Gallimore explains how subtle changes in molecular structure can produce vastly different subjective experiences, even among closely related tryptamines. This complexity arises because psychedelic molecules interact with flexible protein receptors on neurons, triggering cascades of molecular and neural changes that amplify unpredictably through brain networks. Shulgin's approach of systematic synthesis and self-experimentation revealed the vast, unexplored chemical space of psychedelics, underscoring the difficulty of predicting effects from molecular structure alone. Gallimore notes that designing molecules to produce specific cognitive or perceptual outcomes remains a formidable challenge, requiring advances in computational neurobiology and multi-scale brain modeling. Gallimore shares his concerns about the rise of large language models and artificial intelligence, expressing skepticism about their ability to achieve true general intelligence or genuine understanding. He criticizes the over-reliance on AI for communication and creativity, warning that outsourcing thinking and writing to machines risks draining humanity's soul and eroding the art of language. He reflects on the importance of human-authored art as a window into other minds and consciousness, fearing that AI-generated content will lead to a loss of authentic human connection and creativity. Gallimore laments the potential future where original thought and expression become rare artisan crafts, overshadowed by machine-generated outputs, and stresses the need to preserve the uniquely human aspects of language and art. The conversation explores the deeper existential questions surrounding psychedelics and human purpose. Gallimore shares his personal journey of leaving academia to pursue writing about psychedelics, driven by a lifelong passion for books and consciousness. He discusses how psychedelics can rekindle a sense of enchantment with the world, restoring wonder and fluidity to perception that modern life often suppresses. He also touches on the psychological dynamics of meaning-making, referencing research that links fear of death and reproduction to human motivation. Psychedelics, by dissolving rigid mental models, can help individuals reconnect with creativity and purpose, but Gallimore cautions that this process requires sustained effort and integration. He warns against the societal pressures that lead many to abandon their creative dreams in favor of security and conformity. Finally, Gallimore discusses ongoing and future research efforts, including the project to isolate and characterize a peptide that regulates endogenous DMT production in the human brain. Understanding this regulatory system could enable new ways to induce DMT states without external administration, potentially revolutionizing psychedelic therapy and consciousness exploration. He also describes plans to establish a retreat center in the Caribbean where people can safely experience extended state DMT under controlled conditions. Gallimore envisions a future where DMT technology evolves beyond plant-based or synthetic administration to harness the brain's own biochemical machinery, opening new frontiers in the study of consciousness and the mysterious realms accessed through DMT.